All right, I wanted to help you out with these notes for today's class on multiplying two matrices, and it's a really pretty easy process. But the first thing that you should always do, and I've given you a note here in red, is always check the dimensions of the matrices first, because it could be that the matrices cannot be multiplied together. And here's how you check. All right, so you can see my blue matrix is a 2 by 2. I've written the dimensions here. The red matrix is also a 2 by 2. And the way I know that these two matrices can be multiplied together is you take a look at the numbers inside, the inside numbers of the dimensions. In this case, the two numbers, 2 and 2, match up. And so that tells me that multiplication is possible. And the outside numbers have significance also, because if multiplication is possible, then the outside numbers will tell me the dimensions of the answer. So when I'm finished multiplying, I know that I'm going to have a 2 by 2 matrix as a result. All right? So now that we know that multiplication is possible because the numbers on the inside match up, then let's go ahead and go through the process of multiplying these two matrices together. Okay? Well, the thing to remember is always rows times columns. Okay? Keep that in the back of your mind. And let me just walk you through how I would multiply these two matrices together. I went ahead, and I think it's a good idea when you're just starting to learn this. I went ahead and, as you can see, since I know the answer is going to be a 2 by 2 matrix, I just drew a blank 2 by 2 matrix, and I'm going to fill in these blanks with the answers representing the product. Okay? Well, here's the way this works. I'm going to do the elements of row 1 from this left matrix times the elements of column 1 on this right matrix. Okay? Remember, rows times columns. All right? And so I just match up, and I've kind of color-coded them for you so you can maybe keep track of this while you're just learning how this works. The first element, -3, times the first element in the right matrix, -1, and just think about red times red. -3 times -1 is 3, okay? Plus, now I'm going to multiply the second number, 3, times the second number, also 3, and that's 9. So 3 plus 9 is 12. Another way to remember this is this number is sitting in row 1, column 1. So the numbers that I'm going to use in multiplying are from row 1 of the left matrix times column 1 of the right. Okay? Now let's see if I can do it a little different color here. This number is in row 1, column 2. So I'm going to use the numbers from the left matrix, row 1, and times the numbers of the right matrix that are in column 2. And I just match them up. First times first, -3 times 0, which is 0. And then second times second. What I mean by that is the second number, 3, times the second number, -4. 3 times -4 is -12. I always add those products together, and so this number sitting in this position is -12. Okay? Now I'm going to work on the bottom row, and the number that is sitting in this place would be considered row 2, column 1. So think about using the numbers in row 2 times the numbers in column 1. Row 2 of the left matrix times column 1 of the right. and just match them up. 5 times -1, that's -5, plus, you're always adding, 0 times 3, that's 0. And so my result is -5. Okay, we're almost done. And maybe I'll do a different color here. So this is row 2, column 2. So I'm going to use row 2, numbers of row 2 on the left matrix, times the numbers in column 2 on the right, and just match them up. First times first, 5 times 0, that's 0, plus second times second, 0 times -4, also 0. So that bottom right-hand corner answer is 0. Okay, see if we can try a few more. Here's another example. I always check first to make sure that multiplication is possible. And I've written the dimensions of the two matrices, and I noticed that the numbers on the inside, they're both 3s, so I can do it. And the numbers on the outside represent the dimensions of the answer. Okay, so I went ahead and tried to color code these for you as well. So let's just work our way through this. This is the answer. This part of the answer will be row 1, column 1. So we're going to take the numbers, row 1 from the left matrix, times column 1 of the right. And I've just color coded it to make it easy. Green times green, which is 16, plus red times red, which is 24, plus blue times blue, which is 20. And you add all of those up. 16 plus 24 is 40. 40 plus 20 is 60. Okay? Now, row 1, column 2. All right? So now it's going to be this same row from the left matrix. I'll just erase this so you won't see so many circles. All right, yeah, that's good enough. So now I'm going to do row 1 times column 2. So again, green times green, 4 times 7, that's 28, plus 3 times 6, which is 18, plus 2 times 5, which is 10. So you add all these up. 28 plus 18 is 46, plus 10 is 56. Okay, now let's work on the bottom. This is going to be row 2, column 1, so I'm going to use the numbers row 2 from the left matrix times column 1 of the right, and match them up. First times first, green times green, 0 times 4 is 0, plus 1 times 8, here's my 1 times 8, that's 8, plus -7 times 10 is -70. And you add all these up, and you get -62. And row 2, column 2 will come from row 2 times column 2. Green times green, 0 times 7 is 0, plus red times red, 1 times 6 is 6. And then blue times blue, -7 times 30 times 5 is -35. So that result is -29. Okay. That's just another example of what we just did. Let's try this one. I observe that the numbers on the inside match up, and so the outside numbers that I have circled in green will represent the dimensions of the answer. So the answer should be a 2 by 1, 2 rows, 1 column. All right, so let's see if we can work our way through this. Just think about this. This is sitting in row 1, column 1, so use the numbers from the blue matrix, row 1, and there's only 1 column, of course, so match up the numbers. 2 times 2, which is 4, plus 3 times 9, which is 27, plus Negative 1 times 4 is negative 4. So that result is 27. Okay, now work on the bottom. That's row 2, column 1. So I'm going to use row 2 times column 1. 0 times 2 is 0, plus negative 5 times 9 is negative 45, plus 4 times 4, which is 16, and that result is negative 29. So that would be the answer for this example. Notice this one, I write down the dimensions of the red and the blue matrix, but the inside numbers do not match up. So there's nothing I can do here. I'm just going to say that this is not possible. So that's pretty easy. If the inside parts of the dimensions do not agree or they don't match, then multiplication is not possible. Okay, let's try this one. This is a 1 by 2. This matrix is a 2 by 2. So I compare the inside numbers. They do match, and so my result should be a 1 by 2 matrix, one row with 2 columns. That looks like this. 2 blanks going this way. So to get this number in this position, I'm going to do row 1 times column 1. Negative 3 times negative 3 is 9, plus 5 times 5, which is 25. So that first number is 34. Okay? Let's make that a little bit easier. 34. So to get row 1, column 2, which is here, I'm going to use row 1, which is the only row I have, times column 2. Negative 3 times 0, which is 0, plus 5 times 0, which is still 0. And so that result is 0. Okay? And we'll get to this word problem a little bit later, but I wanted to at least give you an idea with this video on how to do matrix multiplying 2 matrices together.